So today we are seeing something about polygon fill algorithms, right? How to fill a given polygon. Now, what do we think? How do we represent a polygon? It can be represented in terms of points. I should say a sequence of points. Like suppose it is x1 y1, x2 y2, x3 y3, x4 y4, x5 y5 and x6 y6. So it will be given in a sequence. So your polynomial, this polygon, suppose I am calling it p1, will be something like a sequence of these coordinates x1 y1 comma x2 y2 comma so on to x6 y6. Okay, so this is your polygon, which means starting from the first point you will connect the second, okay, and so on you will connect to all of them, and the last point will be connected to the first point. Okay, so in this way you will have your this thing polygon. Now we are not actually talking about how to draw a polygon. It is very easy. Given the points between the consecutive this coordinates, you will draw the line, no issues. Now what we are talking about is filling this polygon. This polygon need to be filled with a particular color, so these all should be filled. Okay, so now what do you want, how you can fill it? So there are some algorithms. Let me call the first algorithm to be, it is Scanline polygon fill algorithm. Okay, so in this algorithm we are discussing that we can fill a polygon by going through a scanning line by line. Suppose this is our y, right? You can understand this is y axis, this is x axis. Let us consider the value y. We will keep on increasing the y iteratively from the minimum point to the maximum point. Okay, given these x and y coordinates, we will be able to find the minimum value of y and the maximum value of y, right? Then we can iterate from the minimum value to the maximum value of y, and in each iteration what we have to do, we understand that this y is equal to this y6, right? Y is equal to y6, this particular is y6, right? So this line will definitely intersect, means will intersect, definitely let it be, may intersect some of the lines here of the polygon, right? So what we have to do, we have to consider y is equal to x6 as a line. In next iteration we will consider y is equal to x6 plus 1 as a line, and we have to check whether this line is intersecting any one of these or not. Those places where it is intersecting, we will have to note them down, or I should say what actually we have to do. Let me come from here and then we will start again from the bottom. Suppose this is your y is equal to something, a line, right? So this is your scan line. Okay, on this scan line you will try to find out which are the line and which are the intersection places. Okay, so suppose your intersection was at this point. Let me call it as A1, this is A2, this is A3, and this is A4. So now for this line y is equal to something, this line is intersecting 4 different lines at 4 different places. So now you have these points A1, A2, A3 and A4. Okay, now what you have to do, you have to fill the alternate positions. You will start filling from A1 through A2. You will not fill between A2 and A3. Again from A3 to A4 you will fill. Fill means highlight or shade. Okay, so these are the coordinates where you need to shade it, right? Okay, so suppose you will shade it here, then here, also here, also here. All these places will be shaded. Okay, these coordinates will be shaded. However, after this point it will not be shaded. So again you will start shading from this point. Okay, till here only. So this is the way. Okay, let us start from the below point. What is happening? This is your line y is equal to y6. So suppose it intersects I should say. So whatever the coordinates are there, they will be plotted. Okay, okay. In the next iteration, what is happening? You will find out those places. Okay, it has okay, here it has intersected here, and after that all of the pixels will be plotted. Okay, then here it intersects at this point and all the pixels after that will be plotted. Okay, then what happens? The next thing, it intersects here and all the pixels after this point will be plotted. Okay, so on, no problem, is it? Similarly it will be filled. Now let me talk about this point. Okay, in this particular line, what is happening when it comes at this point? This is the first place it intersects. Let me call it as B1. Then it intersects at here. It is B2. And then it intersects here. It is B3. Now, if we write it as B1, B2 and B3, then what will happen? It will plot from B1 to B2 all these places. However, after B2 to B3 it will leave, right? So in this case what we have to do, since we can observe that it is intersecting this particular line, whatever y is equal to something it would line be, this is intersecting with two lines, with this line as well as this line. Because of this point B2 should be kept twice. So now what will happen? You will plot from B1 to B2 and you will not plot between B2 to B2, and then you will plot again from B2 to B3, right? This will happen. Now let me tell you another case. This case is a little different. Let us consider this case. This is also y is equal to something, a line passing through here. It will first intersect at this place. Let me call it as C1. Then it will intersect. The line is like this, but actually I wanted to draw it from here to this point. So it is intersecting at this point, which is C2, and then it intersects here. It is C3, and then it again intersects here. It is C4. Now here, if we consider the last case that it is intersecting 2 points, let us keep it 2 times. What will happen? C1, C2, C2, C3 and C4. So it will definitely print between C1 to C2, no problem. It will leave from C2 to C2, okay. Then it will print from C2 to C3, and it will leave between C3 and C4, right, which is wrong. Actually what we want, it should print from C1 to C2, and it should not count it twice. It should print from C2 to C3, so it should not print between C2 to C3, and then again it should print between C3 and C4. So these are few special cases that we have to remember during our algorithm implementation, that if such case occurs, that these 2 lines, if it is being intersected at the same point, in that case there are 2 cases. Either we have to keep it twice, or we have not to keep it twice. We have to keep only once. When do we keep it only once? When the other 2 endpoints of the line are in opposite direction. In this case, for B2 you see the 2 endpoints like this one, x3 y3 and x5 y5, these 2 coordinates are on same side. If they are on same side, then what we have done, we have kept it twice. However, if the points like x2 y2 and here it was x4 y4, so these 2 endpoints are in opposite direction, in that case opposite sides from C2, then we will keep C2 at only one time. Then what will happen? You will print from C1 to C2, and you will not print between C2 to C3, and then again you will print from C3 to C4, right? So these are the few cases that we have to consider. Now few more things that I can tell you is how to think about doing it in an incremental way. Okay, the thing is, suppose you have some awareness of the slope of a particular line. It is slope is equal to yk plus 1 minus yk upon xk plus 1 xk plus 1 minus xk, right? Definitely it is the slope. So having known the slope, what will happen? Incrementally you can calculate this slope. Now y coordinate, you can understand that this change, y coordinate is changing by 1. Only x coordinate is something that you are thinking about, whether it changes or not. Okay, so this is the, okay, y is already changing. So what you need to do is calculate xk plus 1, right? Xk plus 1 is actually sometimes xk itself plus 1 by m. Is it okay? You can take this thing on this side, then what will happen? This will be equal to 1 by m. So xk plus 1 will be equal to xk plus 1 by m. So now what happens? By incrementing y by 1, you can easily find out what will be the xk plus 1 using the information of xk as well as m, right? So these are all the stories. Using these incremental things, you can easily draw the boundary of the polygon, okay? And after that, you can find out where it is intersecting and easily fill the polygon. So this was your first algorithm. One thing that I should tell you was coherence. Okay, what is this coherence? Coherence is simply a property, okay, where you should understand that one part of a scene are related to some other part of the scene. Okay, this part is also related to this part, or I should say this part is also related to this part. Okay, somehow it is related, right? So if at all it is not related, then it is not coherent. Okay, however, mostly whenever we have certain scenes, so somehow they are related. So that is that property of having a relation is called coherence. Now because of this coherence, we should use this property in our favor and reduce our processing. Okay, see, the one way is what? Whenever your pixel is coming, for each pixel you can judge whether it is inside the polygon or not. If it is inside, you will plot it, you can, otherwise you will not plot it. So for each pixel you need not check this thing, right? So coherence property here, how we are using coherence property? We are crossing a line that it is intersecting here and here. So in between whatever the pixels are there, you need not check them, you just plot them all, right? So in this way we are using coherence property. So now this is about what I say, Scanline polygon fill algorithm. The next algorithm that we will see will be boundary fill algorithm. What will happen in this boundary fill algorithm? You will have boundary. Let us talk about this boundary fill algorithm in next video. Okay, thank you.